Yo, what's up, Exo? How you doing, bro? Yeah, let's do refactoring. 1 second. I just want to make sure we can refactor before we go into pipelining. Because pipelining is a completely different implementation, so we're gonna have to refactor a little bit. Alright, so yeah, this is switch for decoder. Faster, more readable. Should be like O1 or O of log n, I'm pretty sure. Dispatch table, no, we don't need that. So let's just do the nested switch for the decoder. In here, right? So in here, instruction to string. No, this one's fine. In here, decode instruction. Actually, let me see. 1 second. Okay, intcon fp, right? Is that the last one we implemented? No, we had fcomp as well. So we probably need to implement that in main for a second. So let me just implement that in main real quick. Fcomp. What is fcomp? Let me see. Oh, comparison, yeah, so like FLT and stuff. This stuff. And then this one's already rs1. F class would be, say F class was based off of floating point integer registers, so we said that. That's good. That's fine. But we want the next part. We just make sure the volume's okay. Yeah, I think that's perfect. Alright. So okay, so for this part, we do want these to be separate because I don't think there's anything that follows that, right? So let's just call them fcomp. Yeah. So that would be in our main. What do they follow? So they have RD, RS1, and RS2, but they're depending on the registers. So let me just go read the implementation real quick. So reading floating point registers, storing it into an integer register. So yeah, it should be, let me see. Should be something like this. So we'll get this. And we'll put it in here. Line. But we want to make sure it's an integer register, so it's X here. So that's good, right? That's fine. Got fcomp now, and then I think that's the final one, right? And our thing here, yeah, fcomp is the final one. And now we can start refactoring this. Instead of a long chain of if else, we can make it more of like a jump table, so it's just easier to go find it, like O of 1, possibly O of log n, instead of this long chain of O of n. So let's improve the time complexity with this one. To do that, we're going to be using a nested switch statement. All right, so let's see. So right now we're doing opcodes. Each opcode, and we're checking each condition each time. But the thing is, opcodes are generally shared among these stuff. So let's see how we can implement it. Let's just start with the simple one. I don't want to break anything, so we want to actually like make sure we can do these one step at a time. Hopefully get this all done today, low key. I don't know if we can, but we'll try. once we start getting into a flow, we should be fine. Alright, so let's start with like the R type instructions. Let's just go back. I don't have a page up. Let me go for a second. What was it? risc-v, right? Yeah, risc-v. Yeah, it was Cornell. Yeah, here, this page. I'm gonna pull up this page and alright, so we're gonna start with R type first because that's the first one in our if else statement. So, well, it isn't the first one, but I guess we can start with it. So we have, let's go down to the R types. R types starts here. So those have opcodes of 33. They have a func3 and they have a func7 as well. So let's take a look. That is true. All of them have a func7. So let's see how we can try and do that. So let's just so we're gonna have to do that still. All this is fine. Code func3, func7. We can leave all these variables up here, but we do want to change some stuff here. Oh, also, and it's fine, we don't need the format here, but let's just give it a try. So let's call it a switch, and we're going to be going by opcode actually. So instead of going by opcode, our case will be, it was 0x33, right? Yeah, hex 33. So for the case of hex 33, how did, oh, it's a colon, I believe, is it? Colon? Yeah, it's colon. Let me see. Let me go to my interpreter for a second. Yeah, it's always a colon. Okay. So yeah, for the case of hex 33, wait. Okay, it's on the same line. Okay, so we don't want to indent this. Yeah, so switch case like this. And so what do we want? So for the case of hex 33, since they're all generally the same here, we have, let's just take a reference here. So our R types, it will be all of these. I want to take a look at multiply though. Stuff like this, where we have an opcode of, I'm pretty sure this is 0x33, is it? 0110011. Oh shoot, 0110011, right? It is hex 33, so all R type instructions do have hex 33. And I think we can just make double check. Not in here, in the main, in decoder. Hex 33. We can look for all cases of that. So here, and then as well here. If that's it, that's fine. That's it. Okay, that's good. Alright, for the case of 33, we can instantiate the type like we usually do. It's instruction type, sorry. Instruction type. And call it R. Same with this dot. Well, name will be specific, so for the case of 33, we're instantiating what we need. So usually R's have a destination register as well. So we can instantiate that. And then we also have R's too, usually. So get R's2 and instantiate that with the value. Alright. What else? Oh, they have the rs one. We didn't instantiate that yet. I forgot for a second. Get rs1 value. Alright, so that's good. And I think that's it, right? Let's just make sure. So usually our instructions have rs2, a func7, they have rd and rs1, so I think that's good. Yeah, I think that's perfect. Now we have to look at specific cases and actually implement. So for the case of hex 33, instantiating variables, now we need to actually make another nested case. Now it would be another switch. So first switch opcode, and then it will immediately jump to the opcode and then check func3 as well. So kind of like this, and then specific cases of func3. So I guess, yeah, we can take a look. So actually, well, it's right here. We can just take a look. So our add is 0x0, 0x0. Okay. But I guess there's multiple 0x0s, right? So it's gonna be a bit of work, guys. Just give me a couple to actually get into the flow of this. Okay, so func3 is 0, 0, 0 for these, but 0, 0, 0, 0. It's also 0, 0, 0 for mul. So we want to make sure. Anything else? No, just for mul and those other two. So, I guess I don't want to do another switch for func3 for func7. Are you able to have multiple switches? Like in here, can you do this? Oh yeah, you can. So okay, how do we? So would it be like case 0, 0 and then and like 0, something like this? Okay, I'm gonna write up both implementations and ask Claude actually what's a better perspective to go off of. Let's just write the case for this one first and rewrite. Let's see. So, all right. So for this case, it would just simply be the add one, right? So I guess it would simply just be instant name, just as we usually do it, just an add. I think this is good. I don't know what's a better way to do it. This or like if else statement. Okay, so I'm gonna give this to Claude for a second. Let's just write one more. Actually, no, this is fine. I think he'll know what I'm trying to do. Let's give it a Claude. I want him to see what's a better implementation, because having another if else statement will make it even more complex. But having it like this might be better. This is less readable though, but I guess I don't know. We're gonna have to see. Let's just give it a try. Super switch for that. If we're gonna do like this, we try and do something like this, which would be like if 7 go to 0, 0, then we do. Well, since it's only one thing anyways, we probably just do like this. We can try it in the same line. something like this. This would be another implementation of it. I want to actually see what's better. I have a feeling the first implementation I made, this one is probably better, but I don't know. I'm gonna ask Claude to see what's a better time complexity. Or if they're the same, then I'm probably might do the switch here. It's easier. But let's see. Here are two. I can't type implementations. Which one is? Recommend. Wait a minute. Oh, I forgot the case label. One second. Okay, I forgot the case label. Did I? No, I did. I had the case label. Oh wait, no, I meant another case label. Yeah. Wait. So what's wrong with the first one though? Okay, so it's impossible to use two switches in one. Use two nested switches, that's exactly what Okay, yeah. Potentially be converted by, not converted, optimized by the compiler to a jump table. So potentially O of 1. So nested switch, the compiler almost certainly compiles each switch statement into a jump table when the cases are dense enough. So for the first switch that we have of 1, jump to the right opcode handler, jump to the right func3 handler. If O of n, but n is tiny too, it rejects max. So overall, effectively almost O1 of 1. But yeah, I think, okay, that's fine. Because what we had earlier is this is O of n, like totally, so I guess it won't be too bad. It's actually, yeah, alright. Now that we got that sorted out, we can continue. Alright, so I made a mistake here. It's gonna be case. Oh, wait. Case, yeah, 0x0, I believe. And then further, we do it if check. I think that's not bad. I believe 0x20. Alright, we should start getting into a flow soon. Alright, so sub at 0x20. I'm actually gonna write them down, to be honest. Let me get a pen or something. Actually, you know what? Now would be the perfect time to test out something. Give me a second, guys. Be right back. Alright, yeah. Hey, this is actually the perfect time to test this out. Alright. Let me just get it properly set up on here. Let's just make sure. Nope, it's not set up yet. Hold up. There we go. Yeah, now, okay, that's the perfect time this is the perfect time to test it out here. I kind of wanted to test this out, to be honest. Let me resize this. It's taking up too much of the screen. Yeah, now we have like a perfect like little notepad in the corner so I can draw properly. I don't have to type, I don't have to like do a drawing with my mouse on MS Paint or whatever, so that's gonna be nice. This one we need it, so I think what I'm gonna do is have that like that, and then just so I have a reference. I don't want to keep scrolling back down through this entire if statement, so I'm gonna write down all like the things I need so I can actually like reference it easily, quickly, so I can just type it out, because I want to get this refactor done pretty fast. Hopefully by the end of the stream, to be honest. Okay, yeah. Let's see. Okay, so we have... Alright, so func3 and the opcode. So for the case of 0x33... Okay, we'll do that with the next one. Give me a second. Okay, so we have one more. We have multiplication, so that will be... where is it? Mul, which is func3 and func7 of 1 is 0x1. So we want to go up here again and do func7. Oops, func7 equals 0x1, and have that be... I can't type, bro. Dude, it's so hard to type right now. Alright, okay. There we go. So I think I covered all the cases for that. I believe so. And I guess now we can move on. So we have different cases now, so we can move on. For the AND case, we have the func3 of being... Or should we go, like, in order? I guess no, this is fine. Let's just move down. So the case of... Yeah, I guess we can do that, yeah. So here would be a case of 0x7. I believe that's 7, right? 4, 2, 1, yeah, that's 7. So in case of 0x7, we gotta look at what other has 0x7. Let's see. Let's just take a look here. It's this one as well. That one also has it, so... Yeah, that should be good. Alright, yeah, let's write it out now. It's a case of 0x7. So if our func7 was func7 for this, and is func7 of 0, so 0, 0. That's the case. Trial ended. I don't get this off my screen, bro. Alright, there we go. Alright, insert name equals instruction dot end. Not equal, sorry. You don't even need that. In the case here, func7 equals 0 1, I believe. Insert name. Instruction. Mul something. Or was it? What was it again? It was remu. Remainder unsigned. Okay. That's good. And yeah. We just keep moving like that. So now next case would be something, I believe, let's see. What's the next case? Next case will be 6. We'll do 6. Direct 6. Let's see what all has that. Okay, so 6 here. Nothing else in here has that, I believe. But let's see in here. Anything with 6. Anything with 6 here. Yeah, only this one, I believe. So let's just write it down. Oops. I gotta make sure not to hit that there. And for RAM, the func7 is gonna be 0x1, and the other one it's OR. So for OR, our F7 was 0x0, I believe, right? Yeah, 0x0. 0x0. So now we can go in here and do that. And there's one. And it was red, yeah. Is this obstructing the screen too much? I think it's fine. Looks like you can see most of it. Okay. Next case will be a 4. Okay, so there's 4. And in here as well, let's take a look. Just this. I mean, I guess if they're just 2 checks, it won't really matter if we use the notepad, to be honest. It'll come in handy for more checks where I have to like keep flipping back. If it's only 2 checks, it doesn't really matter for me. I think that's just a waste of time. Alright, so for XOR is 4. Alright, so let's see. For the most part, it's just following the same pattern here. This one ends up being 0x0 and this one ends up being 0x1. I just gotta make sure I do the right one. I don't want any errors here. Okay, that's good. This case. it's gonna be 1. And here. Mul H, and I believe that's the only one I saw. Yeah, Mul H is the only one. So yeah, we can make that optimization here. And what was that one again? Let's see. Shift left logical. And that was Mul H. Mul H. Yeah, I think that's good. They do follow the same pattern of that. Func 7s for the most part here are just that. I guess for now we don't really need this. Let's get rid of that. We'll find another time to actually use it properly. I just wanted to give it a quick test to see, but yeah, I mean, it works fine. Let's see. What else? I believe that's good here. Next case we can work on is this next case. One, 0, 1. So for the case of X5, and I saw a couple different ones. So there's this case, but there's also a case like this. And let's just check each one. So that's SRA, no, SRL and SRA, respectively. Sorry. Hey, what's up, intuitive player? How you doing, bro? And you can take a look in here as well. Div view. Division unsigned, I think that's the only one. And that has a func 3. Func 7 of 1. Yeah. Div view. Couple more cases left. We have a case for 2. And I believe it's only 2 cases. So only stuff like this. And this would be set less than. Set less than. Yeah, set less than, and also one more in here. Let's see. All HSU. I believe that's the only one. All HSU. Alright, yeah. That is the only one. I'm refreshed to find a software streamer that's on Windows. Yeah, I'm still on Windows for like streaming and stuff. I haven't really got into Linux that well. Like I have it on my other PC, like a dual boot Linux Mint and Windows, but and I'm not really seeing the hype. But maybe I'll change my mind as I use it more. I do like the fast boot times though. It boots up really fast. Okay, I think that's the last case, or there's probably one more. Oh yeah, case 3. Case for 3. Case for 3. Should follow the same pattern here. Oops, not there. Here. And it should be set less than unsigned, yeah. Set less than unsigned. And yeah. Opcodes are the same. So less than unsigned. Let's see which is following that pattern. Should be remainder. I think I covered all cases. Let's just count and make sure we have a good head count here. So R type. Alright, so 10 here and 8 here. So we should have 18 in total. So we have 3. Yeah, we do have 18, so that's covered. We covered everything. Double check again. Let's just make sure. So every case in our type arithmetic, let's just make sure we got everything. I think that's the end of it. So as we slowly get rid of those, we can actually get rid of them in here so they don't. So we can keep track. We can slowly remove them from here. Yes. Alright, R type's done. R type's done for refactoring. Alright, let's move on to the next case. So now this would be outside of the switch, so it would be over here. So next case. Let's see. I types, let's see what falls under that. Or let's do shifts. No, let's do I types. I kind of want to follow this format almost like, so we did this so far, all these. Let's do I type now. So we have only 6 in I type, so it shouldn't be too bad. Okay, yeah, let's see. 6 in I type. Well, I guess these also are considered I types. I just wrote them as shifts, but they're considered I types as well. So we have to do 9. Let's see. So their opcode. What is their opcode? Let's see. They should be right here, so I'll reference them much easier here. Opcode is 0x13. X13, and then we can do the variables. Instruction type. Actually, wait, hold up. How would we cover that? So the main reason we split it up like this was because of the main function. We wanted the main function to represent different, because shifts, actually wait, let me see. Shifts, they're pretty much the same. I think we can actually I think we can get rid of the shift and just combine them into I. I should have done this at the beginning, but it's fine. Hey, what's up, Tate Alvi? Bonjour. How you doing, man? Okay, I should have done it at the beginning, but I think it's fine. I accidentally pinned it. Let's keep it here. Okay, I pinned it. Man. I hate that I implemented it like this earlier. Because it's the same way. Let me take a look at the other I types as well. Because this has the same format. It's just the func7 was a distinguisher, which is why we needed that, but now we don't really need that though. Yeah, let me check other I types. Okay, but other I types are different though. but their opcodes are also different. So I guess we can. It shouldn't be too bad. We'll get rid of shift. I'll get rid of shift after I implement. You're doing great. Just a boring Friday. Yeah, that's real. That's real. All right. Okay. Let's give it a try. So you have insta type. We'll just call it overall I forgot semicolon. And we can instantiate get rd, and they also need an rs1 value as well. Okay. How much practice do I have in C++? Just about, I'm guess like almost 2 months now, maybe? Coming up on 2 months. I still have a lot of work to do, to be honest. Okay, so it's a type, instruction type. Yeah, right now we're just at the beginning of this project I made for the decoder a huge if-else block, which would be O of n. It has to like parse through this whole if-else statement. So right now I'm switching to getting these all switched to a switch case statement, a nested switch statement, and this will essentially act as like a jump table. So it checks the opcode and jumps to the opcode, so it doesn't have to go through the whole switch case statement. It can just jump to the one it's wanting to jump to, and then also O of 1 here, and then also O of 1 in the second check for func3. And this part is O of n, but it's really like minimal, like the amount of instructions. It's way better than what I had before to going through a huge block every single time. So that's what we're trying to do right now. You get to subscribe for this one. I appreciate it, man. I appreciate the subscription. Appreciate the sub. Alright, okay. So RD, RS1, and I think that's it. These are considered I types, so that's good. I just want to do a double check for hex 13. What all are considered under hex 13, just to make sure. So these first ones I know. Up until that one. And what else? Is there anything else 0x13? Nothing else at all, so I guess that's the only ones we need to worry about in here. Yeah, okay, that's fine then. Should be pretty simple for this one. And yeah, we want to start with the switch here. Okay, 0x0. Okay, how many 0x0s are here? I think that's it, right? Yeah. I believe so, yeah. That's the only 0x0s that are there. So it's pretty simple. Yeah, that would be pretty simple. So just inst.name. I don't know why I'm so confused there. Inst.name. I still need to get my flow on this part, to be honest. Sorry about that. Okay, yeah. I think it's good. Okay, 0x0, next case, 0x7. Oh yeah, we want that to be inside of this, sorry. Case 0x7. I believe there's no other case for 0x7. No, there isn't, so that's fine. If the case is this, next one, I gotta make sure it's inside the block. All right, the next case, let's see, 0x6. All right, that's good. Or I, right? Okay, 0x4 now. Okay, wait, let me take a look at these ones. 0x5 and 0x1 are the different types. Okay, so I know it won't conflict in anything up here. So X or I now. X or I. Case 0x. Let me check the last. 0x4 and 0x2. Alright. Case 0x4. And that was no, we already had 0x4, 0x2, my bad. Which is SLTI, and that's SLTI unsigned. So set less than immediate. And this one will be set less than immediate unsigned. And alright, next case. Actually, yeah, it's probably easier to just like remove them as we go. So I don't just scroll down. Okay, let's see. We got up till here done. Alright, now we're distinguishing by func 7 as well. So func 3 as 0x1. But I guess that's the only one with 0x1, right? So I guess it wouldn't matter, but I guess it's better to kind of do the check anyways. Just in case implementation changes. So func 7 equals to 0, then our instance name. Oh yeah, has to be in here. Alright, that makes sense. And what was it called again? Shift left logical immediate. Yeah, shift left logical immediate. Now is where it matters though. So for hex 20 for that, so this is gonna be shift right logical immediate and shift right arithmetic immediate. And yeah, I think that's good. We can get rid of these. Oh, and okay, what I'm gonna do for these ones, because you also need to shift them out. We're not necessarily working on immediates. Give me a second, hold up. I forgot this. We do Wait, hold up. Oh yeah, it's not gonna be. It's get m. Yeah. Okay, so that should be fine. I think that's good. For the case of those ones earlier, we had immediate value. Already arts1. Yeah, I think that's good. Only instantiate when necessary. Of course. Okay, now for this one though, it's a different case. It's a bit of a different case here. It's gonna be a shift amount instead. So install shamped, shift amount. It's gonna be get shamped function and call value on that. Dang, I didn't realize we got 3 subs this stream. That's actually kind of fire, not gonna lie. Okay, so insert name, instruction, let me see. SRLI. And yeah, I forgot we need the shift amount here, yeah. So in the case of that. I guess, yeah, we can do that. So an else of here. Okay. Got a bit messy for a second. I think it's fine. What else? What's going on? Oh yeah. Let's just make sure that we didn't mess anything up with the thing. So this block goes to this block, and this block goes to this block. Yeah. Okay, I think it's fine. Yeah. I think that's fine. I think everything's done, right? We can delete these. Already on. Yeah, after I add the shift amount. I do kind of want to check real quick though. So we have 9 instruction drivers. So what's that? 9. And yes, we do have 9. And yeah, so in this case, I'm actually gonna change it. Okay, so let's see the difference. There's not... Oh, right, that was the main difference that I had. That's the reason why I didn't want it to be like that. But now it's not really a problem though, since we're actually like... It's not really a problem since we're actually like... Is it though? Let me see. Okay. I need to see a better way. Let's give Claude this. I kind of want to just see if they have a better implementation. To handle the main function. Yeah, let's just get this. Okay, let's go to Claude, right? Let's give Claude a problem here. Because it is quite a problem. I mean, I guess... Hold up. I mean, I guess we could... Instead of instantiating the type here, we can instantiate inside of here and still keep it the same, I guess. Let's just see what Claude says, though. We'll see. After what Claude says, I'll make a decision. Okay, yeah, he said the exact same thing I was gonna do. That I just mentioned just now. So like overriding it in here instead of it being on the outside, put it on the inside of each so we can actually have it. No, that's really sloppy. Yeah, option 1 is probably the better one. So I low-key had that, yeah. That was a waste of a couple Claude tokens, not gonna lie, alright? I did not even need to ask him. I figured it out before. Okay, yeah, that's a better idea, to be honest. So instantiating each one in here. Let's put it at the top to make it better. And we'll know for the next time we do that. Now in here is where it's different. We actually need the case to be shift instead, so yeah. So then it won't break our main function. And I'll just copy this. Yo, what's up, Zach Tactic? How you doing? From where did I learn C++? From Learn CPP. Well, kind of, but not really. Because on Learn CPP, I'm only about 7 chapters in. It's kind of slow, so the framework that I decided to do was just learn like all the basic stuff like object-oriented programming, structs, vectors, pointers, smart pointers, all that like first. And then as I like any random time during the day, I'll go through a couple chapters of these, a couple like pages of these to actually learn the nuances of them. So that's my plan. I just learned like the main concepts on some YouTube videos or some pages. But yeah, started C++ around like a month and a half to almost 2 months ago. Okay, yeah, this is a better implementation. I think that's good. Let's delete these off. So the opcodes from 0x13 are done. Now opcodes of 0x23 are our next thing. So it's just these 3. Let's see for now. Let's see if anything else has it. No, not really. So I guess those 3 are just special in their own way. These are the save instructions. They're going to be S-type instructions right here. Yeah, these 3. And yeah, we can implement them now in the case statement. They have to be on the, yeah, they have to be at the end of this. So let's just collapse that. Case 0x23. So if that opcode hits that, and we'll do, they're distinguished by func3, okay. So what is 3? And then further cases. Oh, actually, we need to instantiate. So they're all S type, so we can just instantiate the type itself up here. And they all pretty much use the same thing. Yeah, they all pretty much use the same thing, so I guess we can just set the other variables as well on top. Alright, they're all using RS2 and putting the value in that register into the immediate shift, the offset value of RS1. So yeah, we can just get all these variables in here and just have the case be the name. Is there a way to write it on the same line if it's like one? I guess not. I guess that wouldn't really be. Okay, so X1, and that's gonna be H, and then the last one, 0x2. That should be store word, I believe. Yeah, store word. Yeah, that's good. Damn, we got 12 people in the chat. That's nice. 12 people watching. Alright, yeah, that's good now. So for the case of 0x23, we covered those. We can get rid of them. Slowly working our way through this refactor. Hey, welcome back, Rex and Octus. Nice to see you again, man. And just want to make sure there's no more cases of that opcode. Yeah, there isn't. Alright, that's good. Next. Next case, we have 0x something, let's see. 0x63. God, I feel like there's a lot of 0x63s, right? Might be wrong. No, it was 0x53s that were a lot. Yeah, 0x53s have a lot, I'm pretty sure. Like, towards the end, yeah, the 0x53 is a lot. That's later, though. 0x63 is just branch instructions, which is just a couple of them. Just, yeah, about 6 of them. Shouldn't be too bad. So yeah, for the case of 0x63, we want to switch. Their only distinguisher other than that is func3, so we want to switch on func3 and then have our cases. Before our cases, we want to make sure we can instantiate variables. Oh wait, hold up. This should be up here, yeah. I had a feeling that I messed up something there. Okay, so instruction type, they're all the same, so that's good, and then they always the same values, so that's good. we can double check in here. Yeah, I'll use rs2, rs1, and they use a label for branching. Yeah, okay. So that's, yeah, alright. All we need to do is just type the name out now. And remove them as we go. Okay, so there's one. The case is there's 4 now. We have T. X6. BLT unsigned. Okay, so X5 now. Branch of greater than or equal to. Then we have another case 07. I think this is the last case, I believe. For the case of 07, we have branch greater than or equal to unsigned. And I believe that's the end. Yeah, last one. Just want to make sure everything's instantiated properly. Yeah, looks like everything's good. Alright, let's do a quick check with Claude, make sure every case is covered. I just want to make sure. Claude is good for the end checks, just to make sure that I haven't messed up any syntax or anything. I feel like this chat's coming to a close though. Good progress on structure, I'll clear the bug. Good thing I checked. Good thing I checked. I totally forgot about break statements for switch. Because the switch statement doesn't stop once it's there. It keeps going. So we need to do actual breaks. Yeah. So at the end of every case, yeah, wait, did I not do if else ifs? Oh, dude. Wait. Yeah, we don't want ifs, we want else ifs. We don't want this to check any time. So yeah, good catch on that. That's why I like Claude sometimes. It catches out silly mistakes, so I don't dig myself into a further hole. Well, no, the top one should always be if. That's my mistake again. Alright, yeah. I think I did do else if for the rest though. Yeah. And break statements, right? At the end of each case. So for the switch from 3 case, like the specific case, we need to break on at the end of every single one. So wait. Oh, I see why. Okay. Yeah, we don't want it to. Okay, yeah. I don't know why I was confused. We don't want it to go through each one, that's why. I think I got it all. Same here. Well, it wouldn't be inside the SSM, it would be on the outside, right? Yeah, something like that, yeah. Damn. Good thing I checked now, bro. If I have to do this for every single one. Okay, now everything should be good. Oh yeah. Also on the outer switch too. On the outer case, yeah. That's not too bad though. Yeah. Now let's do another check just to make sure. Let's do another check. See if we fixed everything properly. I mistyped something. Let's see. What did I mistype? K0x3 in our R type. Damn, I'm making a lot of mistakes, huh? Man. Is it really not though? Wait. It should be mul HU, not RAM. Let's take a look. Let's just verify. You're right. You are indeed right. Where was RAM for? RAM was for 0x6. How did I miss that? Wait. Oh, okay, yeah. I don't know how I messed that up. Okay, what else? K0x13 is that type is being set redundantly. Oh, I didn't know you can override like that. Wait. Oh yeah, okay, wait, that makes sense. Okay, that makes sense once I think about it now. Okay, yeah, you're right. It can always just be set up here and then overridden in here. Okay, yeah, I see. I totally forgot. Let's get rid of each one. And then only for the shifts are they actually being overridden. Okay. Is that it? Yeah, I know. I'm getting to that. Alright. Looks like everything's good. 0x63 is done as now. Okay, so now we have to do opcode 0x6f, which is just one instruction, so it's fine. It's pretty simple. X6f. All right. It's pretty straightforward, to be honest. There's only one case for that anyway, so it'll literally just be that. And sorry, it should be that. Yeah, that's good. Yeah. Let's recenter that properly. Yeah. Alright. Next case. Can get rid of that now. I believe there's no other jump and link anyways. Alright, 0x37. Let's do checks for that. Alright, 0x37. Don't do anything with that, sorry. It's only one. Oh yeah, looks like only one. So just set everything in. Next case, 0x17. Let's get rid of that. Actually, the refactor isn't that bad, to be honest. I thought the refactor would be much more brutal. I think there's only one, right? Looks like it. Only one. Okay, I like these ones that are only having one. These are nice. Oh yeah. Make it habit, breaks. Put in the break statements. So we don't end up having to put them later. And yeah, that's good. Case 0x3 now. Get rid of this. Alright, 0x3 looks like there's a lot more to do. Let's check how many are there in the function. I think that's it. Yeah, I think that's it. These are the load instructions, so they're also I types, but I distinguish them differently. Yeah, right here. The memory instruction for those, there's about 5 of them. Their opcodes are separate from the other I types though, so they're distinguishable by a certain degree, which I appreciate that. This one is the switch for font 3. And I believe install name. Let's see how much. Let me put this back. Right. Install name. The install type will be the same. They're all the same, and they're all doing the same thing. So all these can be instantiated at the top. And this can be the distinguisher. Okay, 0x0. Yo, what's up, KZ Mans? I'm doing great, man. How you doing? I'm just refactoring right now. Like this huge if-else if block. It's all event, so it checks like every single one, but I'm refactoring to a nested switch statement. So essentially, it's like a jump table. It's all of one. Checks the opcode, jumps to the right value, then checks the func3, jumps to the right value, and then this is all event still, but it's very minimal. It's like 1 or 2, maybe 3 checks. So it's not that substantial. It's pretty much all of one. So it's better than having a huge O event line with the if else if. So yeah, we're getting through that. So it'll be much more efficient in speed once I finish this. Then we move on to the next part of the project. Yeah, I do use Claude to review my code. Like, it catches a lot of my mistakes, if I make any. And yeah, like, I ask a lot of advice from Claude, to be honest. Like, I usually try to think of it myself first, and then I ask Claude if it has any advice, if my implementation's good enough, if it needs any adjustments. Okay, yeah, case 4. Alright, let's load byte unsigned. They're all separate, right? So it should be simple to get them. Load half word is the next case. So case 0x1. Load half word. Case 0x5, and that's gonna be load half word unsigned. Load word, and that's the final one, I believe. Yes. Make sure everything we instantiate at the top. Oh yeah. Breaks for each one. Make sure. Yeah, that's good. Looks to be pretty good. We can get rid of that now. RS1, RD, and intermediate. Yeah, perfect. That's perfect. All right, next case. The next case will be opcodes for 0x67. And let's see. I think it's just literally that one. Jump in link register. Yeah, it's literally just that one. So you can just copy this, put it in here. Let's say break. I think Loki could get this done today, to be honest. It's still a lot, but we're slowly going through. It should start to get... I'm kind of getting in the flow for this one now, so it should be pretty simple. I believe that's only one. 0x7, right? We only want 0x7. I think that's literally the only one, to be honest. Yeah, the rest are 0x73. Yeah. That's good. We can implement that in here. It's literally the only one, so another simple one. Oh yeah. Break. Next case. Our next case will be 0x27, should also be the only one. Yeah. Okay, that's good. Next is, okay, this one's the huge one. There's a lot of 0x53 cases, so we have to make sure we cover them properly. Alright, let's take a look. So the main ones are the first ones here, which are distinguished by funct5. Okay, let's just get this in here. Alright, so these ones are distinguished by funct5. These two over here are further distinguished by a rounding mode. Let's see. The ones down here are distinguished by funct5 as well. But they're also distinguished by their rs2 value as well. Okay. So this music, I mean, it's kind of relaxing. Is it too loud? I can turn it down though, if you want. I mean, I'm pretty sure it's pretty low volume already. But I can just turn it down a little bit more. Alright, 0x53. Okay. It's just those two that are further distinguished. No, those four. These four instructions are further distinguished by rs2, so we probably need a nested. No, we can do one if probably. Yeah, let's try it. And then these ones are rounding mode. Rounding mode and funct5 as well. Damn, okay. Let's just tackle this one at a time for these ones. Alright, for the case of 0x53, they all pretty much have the type in common. No, the type isn't even in common. But I guess, dude. The types are FPA. Yeah, there's quite a difference in the types. So I guess we can, like, kind of, like, override or something. I guess for the top, we can start with these. So like this. And I mean, I guess for not every value has rs2 though, right? This one has rs2, yeah, that's fine. But these ones, no, these ones also have rs2. I believe there's one that didn't have it though, or is that a different type? No, it looks like everything has rs2. I think that's pretty good then. Everything has rs2. Yeah, everything has rs2, so I think it's fine. Keep it up there. Alright, let's start. So the first distinguishers are funct5, so let's start with the switch for funct5. And we just gotta go one by one. What I'm seeing here is that no funct5 actually collide. So it should be pretty simple. So wait, shoot, case 0. And in that case, I guess just that, right? But, okay, no. It's probably going to be better to instantiate it here. So like this. Everything else should be good though. So you can move on to the... Can't type. Okay. Then we can move on to the next case and stuff like that. I don't know if we should delete it. I think we should just have it as a reference or... Nah, that's fine. Our reference is here anyways now, so we can delete it. Alright, for the case of risc-2, we have these two. I think we can do it like that. Yeah. Break statement. Next case. Case risc-1. Yeah. Alright. Should be pretty simple from here on out now. The case is risc-3. We have that. Break. Next case, 0xb. 0xb. Yeah. 0xb. Okay, now it's a bit different here. So now we have two funct5s as 0x5 and further distinguished by an RM, a rounding mode. So let's see. So we have a case of 0x5, but in here we have another if. And it would be RM. So if RM is equal to 0x0, then we can write this min max if yeah, it's not bad. I mean, everyone has different like music taste. This is not like the music I listen to on like a when I'm working out or doing anything like that. It's just like study music for my streams. I barely have it on any other time. I don't know. He doesn't even have to be on the stream either. He can literally leave. Interesting. It's interesting what a lot of people are bothered by, to be honest. I forgot the break statements. We're actually pretty close to the end here for this switch refactor. So I'm pretty happy about that. Tomorrow we can actually start the next stage of the project. I just wanted to make sure we get it in a proper state before we actually move on. So yeah. I think we got it right. If else if break if fman if max. Am I going? Probably after this switch statement is done. I'll probably look for maybe some other refactor stuff, just make sure I haven't. I could do some other stuff on stream if I feel like it. Maybe some other studying for some other stuff. Okay, wait, what did I delete? RM 0x1. Yeah, I think I'm good. Okay. Next case. Oh, we don't want it to be inside this statement. want to break outside. I mean, I don't think it really matters anyways, but still. Oh, is that... No, that's not the last case. That's not the last case for sure. Okay, we're still on 0x53, so let's move down. Okay, so right here is further distinguished by a funct5 as we usually have. So we have the funct5 of 0x18, I believe. Yeah, 0x18. We're actually having a lot of viewers for this stream. Pretty happy about that. Where am I? Where am I at? Okay, here. Do I know Rust? No, I don't. And yeah, that's a mod. Hey. I don't know Rust, but I might want to learn it at some point. Case of 0x18. Yeah, the reason I didn't choose Rust is because it's kind of slow to adopt in the industry as of now. There are jobs, but it's slower to adopt it right now. It might be different like 10 years from now, but for now, C++ remains dominant, even if Rust is superior in a couple ways. In terms of the industry, C++ is still on top, but we'll see how that turns out. I'll learn Rust at some point. I'm still interested in Rust, but for now, we're just doing C++. And where am I at? Oh yeah, this is further distinguished by an rs2. So we can check our rs2. It would be inst.rs2. Inst.rs2. If that's the case of 0x0 and 0x1. 0x0, and then this is I'm gonna take. How about you, Casey Mans? What are you interested in learning? What languages right now? Wait. We took the right one, right? FCBT SW. No, WS. Did I take the wrong one? I did take the wrong one. I took the SW one. I need the WS one. WS. And that's for the case here. Alright, and then WUS. Right now I just want to build stuff with C, which I already know. One day I want to learn CPP and Rust as well. Yeah, I feel like the switch to CPP won't be too harsh on you. Rust might be a different case though. And yeah, it seems like you're interested in building stuff with C. Do you have like any idea of what you're gonna build? Or not yet? WS, okay, that's good. Now I want to get rid of those so I don't get confused. Just make sure I got everything. For the one for 0x18, it's WS and WS. It looks like we got it. So we can remove those. Now here, not yet. Yeah, that's fair. Right, okay. I believe it's 1A, and it's further distinguished by, it's the same, I believe, inst.rs2. I'm low-key, like, hyped to actually move on to the next stage of this project. I'm getting so tired of typing these. like install names, install types, and all this stuff. I've been doing that for so long. All right, let's see. All right, it's yeah. SW and then yeah. Looks like that's good. Break statement. And yeah, we can get rid of those now. Make sure we're getting rid of the right ones, not going too far. Just those two. Yes. Alright, next there's a couple more. Is our X53, and then we have a couple more up here, and then a couple more on the bottom, and then it's done. Here, finally finished refactoring after that. Alright, so for these ones, it's also funct5, but further distinguished by 0x1. So, let's see. Where are we? We are gonna be right here. Yeah. Are we right here? Yeah, this is the funct5 switch, yeah. Case of 0x4. And a further case of RM of 0x0 and 0x1, and also 0x2. Okay. Okay, that's good. I think I'll just get rid of them as I go so I don't get too confused. So that one's done. We need this one. The next one is go to 0x2. These two. And get rid of it. Okay. Looks good. I just want to make sure. Yeah, that's good. It's good. Of course, we need the break statement, of course. Alright, next ones are going to be case 0x1c, and it looks like only one is there for 0x1c. Is there only one for 0x1c? Nope, there's more. Good thing I checked. Looks like we have two cases for 0x1c. And yeah, okay. I believe that's good there. Let's delete that. Hold up. This one. And then the class. This one, yeah. Let's delete that as well. That's good. Break. This case. Got a couple more cases left for that. Okay, so 0x53. This one is distinguished by funct5 only, so I think that's the only one. It's 1e. Not weak, break. Okay, have I been putting breaks for everything? just to make sure. Well, Claude will make sure anyways. He'll make sure I didn't make any mistakes for the breaks and stuff. Next case, 0x14, which has 3 different cases. 0x14. I think that's the final one, right? 0x14. If our rounding mode is 0x0. Check. If it's 0x0, it's going to be probably S. Else if 0x1. It's going to be this. X2. And 0x2 will be this. Yes, that's good. And break. We can delete these 3 now. Alright, how many more do we have left? 1 in 43, 1 in 47, 1 in 4B. Oh, what is this one? Oh, E-break. Yeah, okay. At the home stretch here. Let's go. Alright, so we're out of here now. For the next case of opcodes, 0x43. Wait. Wait a second. I mean, it should be going, right? I'm sure it's fine. Hold on. I don't know why it's not going to the end there. I think it's fine. Not a big deal. As long as it's not a part of this branch anymore, it should be fine. Because that branch starts here. And that branch ends. Oh, wait. I see why. I think I see why. Hold up. No, wait. I don't want to see why. Hold up. Yeah, no, that branch should end there. I think I'm just overthinking things right now. I think it's not really a big deal. Alright, let's instantiate variables for the next case. Or no, we don't need to instantiate, we can just copy it since it's only one. Before we move on, I actually want to check though. Give me a second. I appreciate that, I appreciate that. Let's give this a little check, I just want to make sure. All the way down here. Let's give it a little check. Let's see. 18 FC BTWS. Did I do the wrong one? Oh, that's right, because I copied it wrong, yeah. I ended up copying it wrong, that's why. FP copy int. How's that wrong? Alright, Claude. I got it right though. I got that one right. I guess that was just a little miscalculation on Claude for that one. But yeah, thanks for letting me know this, Claude. Appreciate that. Yeah, no, I haven't gotten to that yet. I just want to make sure everything's good though for here. I guess, yeah, it's fine. I guess my only problem is that it's not going there, but I guess we can do that. And then it'll be fine. Next case. For the case of 0x47 now. Right, so for some reason that one wrapped automatically to the thing, but I don't know. Why did that happen? That actually really confused me for a second. Alright, for B. That's good. That. Case for 0x4f, and we have that. All these are different opcodes, so it's fine. Alright, the last three. Well, this one's kind of just like there. As like a default case, I guess we put it as a default case. I think that's what you do in a switch case, right? You have a default case at the end. Else if here for this one. Let's do it. So let me break for this. And get the case for this one. So case 0x73. And this is further by font 3. Case 0, and that will be wait, hold up. I totally forgot. Why did I do that shift again for that? Oh, okay. Okay. Right, it's further by func 12, but where do we know that though? Let me check. E-break. E-call, okay, yeah. I remember now. They have a separate func 12 field, so I just made that up on the spot there when I did that part. Right, I remember now. Okay, yeah. This will happen only if it hits that case anyway, so. I guess just copying that. .12, eBreak environment, yeah. Well, we can instantiate the type at the top, since they're both gonna be the same either way. So, we can put this at the top too. Or I'd rather have this on the very top. Alright, okay. And then get rid of these. I think refactoring is officially done now. No, we need the default case. I forgot how to do default. Default is just like, is it literally just this default and then I'm pretty sure that's how you do it. And then returning it at the end. Oops. Alright. Yeah, that should be good. Let's look at the case here. Well, I guess I just wrote like a regular case though. We also need break statement. But yeah, let's just check this function. So now we have officially an almost O of 1, an O of 1 jump table essentially. Almost O of 1. Okay, let's see. Almost everyone is flag. A break before default. Did I not put a break before default? Right. Break here outside. Grab the case and braces. Oh, okay. Actually, didn't know that. Wait, okay. And I guess, yeah, we can make this just a one-liner if that'd make it easier, to be honest. Okay, yeah. I want to make sure it's the same structure here. So he has a break, he has a brace. Wait, so where's that brace? Closing, wait, hold up. This break starts here. Ends here. And this one's the overarching one. Oh wait, no. That's for the whole case. So okay, that's not the overarching one. That's the whole case. So the brace starts here. And would end here. Or wait, what the? What up? Something like that, wait. Give me a second. We're just gonna put this all in there. so it's formatted right, and I think that's fine. I think that's good. Alright, so the brace out here, this. Yeah, essentially we're good. Alright, now one last check. Correct, all statements are in place. The case RX73 is probably wrapped in braces, and the default case handles unknown instructions. Refactor is complete. Alright. Actually, we did that pretty good. That wasn't actually that hard, to be honest. So now this is essentially an O of 1 jump table instead of our O of n flat if else long chain. So now this is better. Anything else? This looks fine. And already this case statement is pretty optimized. I guess tomorrow we'll get started on our next part of the project. Let's see. I do want to make sure that it's 100% good though. 1 second. Oh, did I close that tab? Oh, damn it. Okay. We'll go ask Gemini. Alright, give me some risc-v 32-bit instructions. Well, I want the strings, so bit strings for instructions. Let's just do a couple test cases. So what should we do? Let's do one from this one. So let's do an add. Let's do a SCTU. Oops. Let's do a shift 2 as well. Let's do like 2 more. Load byte. And let's do one floating point instruction. Let's do fdiv signed. Div signed. Just print out each string. Tell me the instruction for this. Alright. I don't want spaces. Alright. I guess that's another thing to tackle later, so they're not spaces, but our next implementation will be adding files so that it can just take a binary file or ELF file, so we don't have to do manual input. But for now, we have to do manual input, so let's get rid of the spaces, please. Alright, okay, now we can check to make sure everything's good. Alright, so required assembler, add x10, x11, 12, x12, that's pretty good. Let's keep going. SLT x5, x6, x7, SLL x1, x2, x3, LB x10, offset of 4 of x11, and the last one fdiv.s f10 f. Well, that's a more simplified version of how they actually represent, but this one's correct. This one's correct. I haven't gotten to that part yet where we actually distinguish between A1, A0, and like actual naming, but this is fine. So that works. I think we should get like a testing suite or something, right out like a test application, but we'll probably do that on a different stream. I think for today we're done though. W stream, and yeah, I'll see you guys tomorrow.